Welcome back, students. We are still on the topic of conservation of momentum, but today we're going to learn about inelastic and elastic collisions. We're mainly focusing on elastic today, but I want to explain what those are. Okay, in physics there's two types of collisions. There's elastic collisions and there's inelastic collisions. So elastic collisions are collisions where the kinetic energy is conserved. Of course, energy is always conserved, but in elastic, it all stays as kinetic, even before and after the collision. In an inelastic collision, some of that kinetic energy is lost to heat and sound. So this might be like a car crash. When a car crash happens, a lot of motion is lost and there's a big sound and a lot of heat released. So that's where that energy goes. And something like a bouncy ball striking another bouncy ball, that's a fairly elastic collision because there's not a lot of sound. They just bounce off each other, and a lot of that kinetic energy is conserved. Okay, so just to clarify what an elastic collision is, it's whenever the kinetic energy is conserved. If I were to write that in equation form, it would look like this. Okay, so it says that the kinetic energy initial equals the kinetic energy final, and I can write that out more explicitly like this. Alright, in the case when there's two objects colliding, I can write this out like this. Okay, so all I've done here is I've written kinetic energy for both the object 1 and object 2 for the initial state on the left side and then the final state on the right side. And kinetic energy is this 1/2 mass times velocity squared. So I'm going to have one of those terms for each object before and after the collision. And then before, the initial state is going to be equal to the final state because it's conserved in an elastic collision, in addition to the momentum being conserved. Okay, so in an elastic collision, momentum and kinetic energy are both conserved. And in an inelastic collision, only momentum is conserved and the kinetic energy is not conserved. Collisions where two objects like bounce off each other are usually elastic, but sometimes you have to check the math and it could be inelastic still. But collisions where things stick together tend to be inelastic. So if a car runs into another car and they just slide together after the collision, that's going to be inelastic. So just keep an eye out for examples that have things sticking together after the collision, because that's going to be an inelastic collision. Okay, the last thing I want to do is run through this example. I did something similar to this in the last video where I had two boxes colliding into each other, and I knew their masses and velocities before the collision, and after the collision I only knew the mass and velocity of the first object, and I was trying to find the velocity of the second one. So I'm going to do a very similar example. Then I'm going to test, is this elastic or not inelastic? And I'll show you how you can find out if it is or not. Okay, so the easiest way to find the velocity is to use the conservation of momentum, which looks like this. Okay, this just states that the mass times the velocity for object 1 and object 2 added together initially are going to equal the mass times velocity for object 1 and 2 added together after the collision. Okay, if I plug my numbers in, I can solve for V2, which is my unknown variable. Okay, here I plugged my numbers in. All my masses are 4 kilograms, so I put a 4 for every single m. And then the velocities are 3 and 2 for the initials, and then 2 for the final velocity of object 1. Okay, if I crunch these numbers, here I got 4 times 3 is 12, and then 4 times 2 is 8, and then here I have another 4 times 2, it's another 8, and then here I have plus 4 kilograms times the unknown velocity. Okay, if I subtract this 8 to both sides, it'll cancel with this one, and then I divide 4 to both sides, and then of course 12 divided by 4 is just 3. Okay, so I know that my final velocity is 3 meters per second. Okay, so if I know my velocity is 3 meters per second, I'm going to pull that to the side here. Now I'm going to check if this collision is elastic or inelastic. Okay, so I mentioned that in an elastic collision, kinetic energy is conserved, so I'm going to write that equation down here. Okay, so I have my kinetic energy initial for both object 1 and 2 is equal to my kinetic energy final for object 1 and 2. Now I'm going to plug in my numbers and see if this holds true. Alright, so this is a lot of numbers here, but I have my masses and velocities plugged in for all these objects. Okay, on the left side, I have 1/2 4 times 3 squared. I also have the same term over here on the right side from the second object after the collision. So I have 1/2 4 times 3 squared on both sides. I can subtract that from both sides. And the same thing with these two terms. These two terms are also the same thing. 1/2 4 times 2 squared, and 1/2 4 times 2 squared here too. So those can also cancel. Okay, so then I know that the kinetic energy is conserved, so this is going to be an elastic collision because of that. Just in case you aren't convinced that you can just easily cancel things out like that, I'm going to go ahead and do the math too, just so you can see that the left side equals the right side. Okay, so here I crunch the numbers out, and this term comes out to 18 joules, this one comes out to 8 joules, and since they're the same terms on the after side, they're just flipped. This is going to be the same thing, but 8 and 18, which comes out to 26 on each side. So there I can see that kinetic energy is conserved, so this is an elastic collision. Okay, if I got something that wasn't the same before and after, then that means that some energy might have been transformed into sound or heat, and that would be an inelastic collision. Okay, we'll explore inelastic collisions in a couple days. I hope this video helps you guys understand how elastic collisions work and how you can identify those. Okay, thank you guys. See you next time.